What is planned to do is a slingshot that launches a cell phone with different angles of inclination and measure the distance to which the cell phone arrives. Then, by the analytical method, we will check if the distance is the same.
The objective we have with this project is to find the distance that a cell runs when being launched with a slingshot and check it analytically.
First, let's pretend we just have a rock and we are throwing it with the slingshot. What we did was measure the range that the cell phone reached when pulling back the lead 67 centimeters. We did it with the different angles to compare them with different ranges.
With the data provided by the application of accelerometer, we obtained different data of the velocities in x, y, and z. We took the highest value of each axis, and since we had the three components of the acceleration, we calculated the magnitude of the velocity by the formula. Magnitude of the acceleration equals to square root of the acceleration in x squared plus acceleration in y squared plus acceleration of z squared. Then we substitute the magnitude of the acceleration in the formula. Final velocity equals square root of 2 times the acceleration times the distance. Finally, we clear the distance and calculate it with the formula. Distance equals final acceleration squared over 2 times the acceleration.
According to Newton's law of inertia, an object in motion in a horizontal direction would continue in its horizontal motion with the same horizontal speed and direction unless acted upon by an unbalanced horizontal force. If these two motions are combined, vertical freefall motion and constant horizontal motion, then the trajectory will be that of a parabola. In this case, we will call this situation the parabolic motion. An object which begins with an initial horizontal velocity and is acted upon only by the force of gravity will follow the path. It will travel the same horizontal distance in each consecutive second, but will fall vertically at a greater distance in each consecutive second.
The results we obtain experimentally have a minimum error range compared to the results we obtain analytically.
One of the main recommendations is that when taking the acceleration, it is better if you take the maximum point of the components in x, y, and z. Another recommendation would be not to take the average of all components at x, y, and z. This is because the result is more accurate if the maximum point is taken. Using the accelerometer app is highly recommended because it saves 30 data in a single second on the x, y, and z axis.
As conclusion can be said that with the data that the app sends us, it can be obtained the acceleration of the cell phone when thrown with the slingshot. And once you have the acceleration and we were able to clear the distance and check that effectively when taking the maximum points of the components, can get the distance with only a minimum margin of error. What we learned as a team was that with the help of tools that already exist, as the accelerometer, we can find the distance and acceleration of an object.